I don't want to do this one. We'll do this one. I'll set this one up. I'm not going to go. I'm going to. You're just going to have to believe me on the calculations because I don't want to spend the time doing calculations. Okay, so you'll see nodal analysis called all kinds of different things in different books. The book I got this from calls it node voltage. It's just a different way of referring to it. So use the node voltage method to find the steady state expression for I in the circuit below. So we're trying to find the current through the 1.6 millihenry inductor. And I'm going to go through this pretty quickly. So we know that omega needs to be, is going to be 2,500, and we get that from our equations. And we know that our capacitors are minus J over omega C, and the inductor is J omega L. And when we do that, and also look at our voltage source and our current source, then this transforms into the current source becomes 5 angle 0. And the capacitor is minus J4. The voltage source is 20 angle 90. This capacitor is minus J8. The inductor stays 12. The resistor stays 12. And the inductor is J4. And then I will call this V1 and this V2 and this ground. This node I'm not going to label because I know what the voltage is there. If this is ground, then the voltage here is 20 angle 90 degrees. So then my voltage equations are starting at V1. So when you're doing a nodal analysis, currents coming in are negative. So that's minus 5. And then everything else will be V1 minus the voltage on the other side over the impedance. So plus V1 minus 20 angle 90 over negative J4 plus V1 minus V2 over minus J8 equals 0. And then my second equation, starting at V2, so I would have V2 minus 20 angle 90 degrees over 12 plus V2 over J4 plus V2 minus V1 over minus J8 equals 0. Now, while this would be a reasonable problem to do on a take-home quiz, or would not be bad if these were all real numbers. This becomes pretty tedious to do unless you have, is that an Inspire CAS? Okay. So if you have an Inspire CAS or an 89 titanium, it's not so bad. You just plug them in and it gives you the answer. But any other calculator, this becomes kind of a pain to do. And so it would not be on a test problem other than to set up these equations. And so at this point, I'm not going to spend the time solving these because Kramer's rule or, I mean, there's not a nice way to solve it. What do you have? Oh, okay. I was hoping you had a fancy calculator that I didn't know about because I love fancy calculators. But anyway, so yeah. So probably, I mean, if you had to do it by hand, you know, Kramer's rule, or it's probably the best way, even though I really don't like Kramer's rule. But there it is. Okay, so if you decide you want to go solve this for fun, V2 is minus 8 plus J4. And I, so let's see what I would be. I is the current down that middle branch. So I would be V2 minus 0 over J4. So I is V2 minus 0 over J4. And now that we have V2, minus 8 plus J4 over J4. And that ends up being 1 plus J2, or 2.24 angle 63. And then if you needed to write it in the time domain, which is what the directions actually say to do, that would give you 2.24 cosine, and then our frequency, our omega was 2500 T plus 63 degrees amps.
I have a question about your V2 equation.
Yeah.
Shouldn't it be like there'd be a -5? Because when you're looking at V2, when you see V1, the current is entering that node, so there's still supposed to be a -5 there, right?
For V2?
Yes.
No.
Okay.
No. The 5 is entering V1.
Oh, and let's say we didn't know what V3 is. Would there be a -5 there also? Would there be a -5 there or no?
No.
So it'd be only for finding V1.
Yeah, the current from the current source is going to be involved with the nodes that the current is going into.
Yes.
But you're not going to apply it to other nodes because that current is not. I mean, if you know what the current is on any branch, you can use it, but we don't know the current in any other branch other than the one where the current source is labeled.
Yeah, but wouldn't be the current going through V3 theoretically be also 5 because it enters that? Well, it wouldn't be -5. It would actually equal to 5 because the node. No.
It's not at all -5 because once it's only -5 in the little branch where it is.
Oh, yeah, because it splits KCL. Okay, that explains.
Okay, any other questions? All right, I'm going to keep going on this. Yes?
So if the current source is leaving V1, would it be +5?
Yes, it would be, right. So when you're doing nodal analysis, current going into the node is positive and current going out of the node is, current going into the node is negative and current going out of the node is positive.
So it'd be +5 for V3, right?
No.
Okay.
V3 it's not part of V3.
Okay.
Yes. Yeah. It's just not.
For some reason, I just thought it really would be.
Well, it really is not.
Okay.
Okay,
I believe you.
yes. Okay, other questions? All right,
What are the odds, I got a question.
yeah.
What are the odds of having multi-source circuits on the test? Like, those take a while, and we have 6 of them to do, 6 questions to do in general. Wouldn't that hurt?
I would say,
There might be
I don't,
one.
yeah, maybe 1, 2. I don't know. I mean,
I'd say one.
I guess, honestly, I would be surprised if he gave you a circuit where you had to find a current or a voltage and it would not be multi-source because it's circuits 2. So there will be problems where you might have to find an impedance that, that's different, but anything, so of the 6 questions, probably I would not expect more than 2 of them to be heavy-duty circuit analysis, but of those, I would expect them to be multiple sources. So I honestly don't remember from previous years. I will look, and if I have I'll look back at my notes, and if I have an answer different from that, who asked that question? If I have an answer different than that, I'll let you know, but I would suspect, okay, so what I would say is one thing I've noticed about his test as the years have gone by is the problems have gotten easier, but he's giving more of them. Like back when I took the class, our tests were 2 problems, but they were hard. I mean, and they definitely used the whole time for all 2 problems. So now there's 6, but they're easier, but you still need to really budget your time. So what you want to be on the lookout for is look at the point value. And if the point value is not very high and you find yourself spending a lot of time on it, you're probably not doing it the way that was intended. The ones with the higher point values are going to be the ones that take more time. And so you just want to be careful on that and budget your time accordingly. It should all be doable. In recent years, the tests that I've seen, I could sit down and do, I'm very slow. I could probably get them done. This is going to sound weird coming from the SI, but just keep in mind I am very slow. I get double time on my tests. But I could probably do the Circuits 2 test in the 50 minutes that y'all have. Knowing that I know it really well. But even so, I'm slow. So you just, that's a way of saying it's long but not too long. I don't know if that's helpful at all.
I know students from past semesters said that the hardest thing was the time budgeting on the test.
Yeah. I have, like I said at the beginning, I have the real bad habit of getting bogged down in a problem. Like I said, I would have done the first problem and find that I didn't have the right answer and spend too much time on that. So try not to do that, and I would, work to your strengths. If you find that there are certain kinds of problems that you do better with than others, go ahead and do those and get them out of the way and get those points, and don't waste your time and not get the points that you know you can get. Make sure you do the ones you know how to do first, and don't attack the hardest problem first because you know you need the most time, because then you might risk not getting the points on the stuff you do know. I know it's late in the day. I probably won't have time for this. If I do have time, I'll see if I could put together something that I think would be about the length of a test that he would give, so you can see it. But I don't know. I also just inherited Circuits 1, and they have a test on Wednesday, and so I'm going to start meeting with them as well, because I haven't seen them at all. So, all right, where am I? I am about to do another problem. The equivalent impedance as seen by the source. I guess I'll stop the share. Other questions?